and then we'll talk about them. Give an example of a type 1 improper integral. Give an example of a type 2 improper integral. And then what is the first step in evaluating that third improper integral? We did all of this, what was it, a week ago? I guess we did it a week ago today on Monday, last Monday. Then we took a little break. Well, we did practice on Wednesday, and then we took a little break. All righty. It's good that you're left hand. Unless you're a lefty. I know lefty. Oh, that's good. Yeah.
So,
Yeah. Yeah, there you go. Yes, it is. Very nice. There we go. Are you ready? Let's talk. Type 1 improper. So where somebody in a big sense, what makes an improper integral? Where do they occur? Why do they occur? How do they occur? The limits mess up. Okay. Why do we got mess up limits? Because what?
The infinity.
Because our region, our area is unbounded, right? You run into improper integrals. Let me just put down, right? We run into improper integrals when we have asymptotes, right? Sometimes we have a behavior where our function is going towards a vertical asymptote, right? And so we have this unbounded area. And sometimes we have where our asymptote is a horizontal asymptote, right? And we're looking at another unbounded areas. So improper integrals often occur when you have unbounded areas. Okay, that's one way to think about when they're occurring. They occur when we have unbounded areas, okay? Type 1 happens. Give me an example of type 1. Somebody give me a type 1. Go ahead, AK, go ahead. Integral from 1 to infinity of 1 over x squared. I like it. Or x squared. X squared would automatically be unbounded for sure. I'll put 1 over x squared because it has like this asymptotic behavior with it. That is an improper integral. And which case are we in? We're in the case here where we're going to send our x value to go to infinity, and we've got this asymptotic behavior occurring. Are you with me? So this would be a type 1 improper integral whenever you see the infinity or negative infinity at that endpoint, okay? And that occurs when you're looking really at a horizontal asymptote. So if I want to get really technical about it, what's happening is I have this horizontal asymptote and my graph is heading towards that horizontal asymptote, getting real close, and we're deciding what's happening to that area. Is it blowing up or is it shrinking? How about the improper integral type 1? That's more when you have a vertical asymptote going on. That's when you have a problem. You have a vertical asymptote and you're looking at the area as it's going towards that vertical asymptote. What's happening at that unbounded area? So, somebody got an example for me. Go ahead, Jaden.
Let's just say the limits are 1 to 10.
1 to 10, okay.
The 1 over x squared. That's a good one. Or 1 over x cubed.
Very close. For that to occur, we would have to have, I like that, we would have to switch it, thank you. Let's put a 0 in there because those occur when you have asymptotic behavior, meaning there's something here that you can't plug in. So if I go from 0 to 10 of 1 over x squared, that would absolutely be a type 2. If you want to plug, let's just say I go 1 to 10, can we alter our bottom a little bit and make it like x minus 1 or x minus 10, or 2, absolutely, 2. Why? Very good, yes. So this would be a type 2. This would be integral, whoa, Tina, draw this. Integral from 1 to 10 of 1 over x minus 2 dx. Why is that guy improper? Because what's my bad value? 2, and 2 falls in that integral, right? So that causes this vertical asymptote to occur. That's a type 2. Does everybody understand what makes an integral improper? Type 1, type 2. Okay, that's the first step, all right, that I need you guys to make sure you know. What is the first step in evaluating an improper integral? What do? We, in words, Laura, change it to a limit. We change it to a limit, right? So the first step is to change to a limit. And can we take that integral and change it to a limit? Walk me through it. What would we do? We would say the limit as TBA, something goes to infinity. So we would figure out where our problem is in our integral. And we would then send that problem to, you would take a variable, replace that variable in your integral, and send that variable to the problem, infinity, 0, 1, 10, whatever the problem is, okay? Any questions? Everybody's good? Everybody's okay? So we are going to practice and do one example because we did some last week, but I'm going to get rid of this guy. I want you to evaluate this improper integral right here. Let's evaluate this improper integral right here. I want to take the integral from 1 to 8 of 1 over x times the natural log of x of 0.4. That is 0.4. It's just like one of your homeworks. They have some weird exponents. That's 4/10. Or if you like fractions, that's 2/5, right? So you could either view it as 0.4 if you really like decimals. Me, myself, and I really like fractions. So I would rewrite 4/10 as 2/5. 4 over 10 turned into 2 over 5. Okay? Either one. But write your first step. And let's evaluate this down. As you guys just said, okay, 1 is a problem. The reason 1 is a problem is because the natural log of 1 is 0. We can't divide by 0, which means we've got this asymptote. So when we looked at that picture on Desmos, we saw asymptotic behavior happening right here at 1. So you're rewriting your limit, and your very first step should be to say the limit. Oh, hang on here. The limit as t goes to 1. But, okay, all right, so now we have to go back to calculus 1. When you say limit as t goes to a number, you're talking about both sides. You're talking about a two-sided limit. But for our purposes, we are only looking at one side. Are you with me? We are looking from the right side. Are you with me? So what do I put up there on that number 1?
Was it a plus?
It is a plus. There's a little plus that goes up here because it says we are approaching the asymptote of 1 coming from the right side, or the what we call the positive side, versus the other side, which would be the negative side. Are you with me? So when you go to rewrite this limit, you want to designate that we're only coming from that right side. So the limit as t goes to 1 from the positive side, t to 8 of 1 over x times the natural log of x to the 2/5 dx. So we rewrote it as a limit. Now we have to evaluate it. All right, we're still in Calc 2 space here. How do we do that? U sub. AK says U sub. How many of you guys think AK's good? Gonna sit next to him on the test? Absolutely U sub, right? I like U sub. You like U sub? All right, so you guys are doing U sub. You're gonna let U be somebody other than AK and Gavin. U be what? ln of x. Thank you, Jaden. U is ln of x. Perfect. Du is 1 over x dx. This is a Calc 2 technique that we've been practicing, and Calc 1, but we've been practicing this sucker. So we are going to rewrite this limit. So I'm going to rewrite this limit as t goes to 1 from the positive side of t. I'm switching things into u. So I'm just going to put a little note here with x. So I'm going to remind myself that t is an x value. okay? Or you change your limits. I don't care if you change your limits or you remind yourself that those things are X numbers and not U numbers. So however you want to do it. Most people tend to be not wanting to change limits. So I'll keep them there, but I'll denote that that's an X number. So what do we got? We got, oh, what do we get? Yusuke, what did you get when you plugged in the U? You got something for me. So you got U to the negative 2/5 du, right? That's exactly what you did. U to the negative 2/5 du. Or 1 over U to the 2/5 du. Because the 1 over x dx got translated into du, and then ln of x became U to the negative 2/5, or U to the negative 0.4. And then, did you guys integrate, take the antiderivative? Add 1. U to what? What'd you get U to? Lilith?
To the 3/5.
3/5? U to the 3/5, or 0.6, I guess, if you're going to do it with the decimals. So U to the 3/5, and then what's in front? The 5/3? 5 over 3? Thank you very much. 5/3. And we're going to go from at 8, but again, 8 is an X limit. And T is also an X value, so don't even think about plugging those in until you go back and put in for U, right? So then everybody's going back and replacing for U, and so everybody's getting the limit as T goes to 1 from the positive side of 5/3 ln of X to the 3/5 power. Now I can get rid of those little notations, and I'm going to rewrite one more step. On your homework, some of your web work problems require the first thing, which is rewrite as a limit. So that's the first thing they require. But they also, 1 or 2, I can't remember how many, ask you to put this step in there, which is, what do you do once you plug your limits into, or your values in for your limits? So they'll have you put this step right here into the computer as well. So I just circled them because web work, one of your problems or 2 of your problems makes you evaluate it up as a limit, and then the other piece that they ask for is, okay, now that you've worked the integral out, what is the limit that you're going to be taking? They actually require you to stick that in there. So now we evaluate this limit, and this is where Calculus 1 comes in. So now we're done with Calc 2, and we go to Calc 1, and we plug in our limit. Oh, so let me see. That means I have 5/3 times the natural log of 8 to the 3/5 power minus 5/3 times the natural log of 1. Can I plug that in there? What's the natural log of 1? The natural log of 1 is 0. This sucker 0. So what would we say about this limit? This limit actually goes to the natural log of 8 raised to the 3/5, or 0.6. Number here, is this finite or infinite? This is finite. Natural log of 8 is a value. This is finite. And if it's finite, what do we say about the integral? The integral does what? It converges. If you have a finite answer, you say that your integral converges. Question, Reese.
On the web work, if
Yeah.
it diverges, is that the answer that it will?
It depends. Your web work is funky. Sometimes it'll say, does it diverge to infinity or negative infinity? And it prompts you to read the problem and say, put INF if it goes to infinity. Right, Hannah? And sometimes it says negative infinity. So you have to read what it asks you to put. On your test, I will want to see what is the limit equal to, if it's infinity or negative infinity. And then I will say, does this integral converge or diverge? Circle. And then you'll have to circle whether it's converging or diverging. Okay? Any questions? Any questions? Yes, Reese.
Like if you got like a negative for that, like if the ln of 1 was
if it was like negative infinity or negative 0?
Like negative 5/3 salad at 8 for 3 fish.
Yep, that would still be okay. Uh-huh. Any questions? Other questions? I take a moment to talk about something called a p-integral. A p-integral, and I know it's really small and it's hard to see what's going on here, so let me add a couple things here so you can see. In all of these three cases, we are taking an integral where we're looking at the area under a curve that starts at 1 and goes to infinity, okay? And in the first case, I know it's small, this first function is 1 over x squared. The second one is 1 over x. And the third one is 1 over the square root of x, which is 1 over x to the 1/2 power. These are examples of what we call, I spelled it all wrong. These are examples of what we call p-integrals. A p-integral is an integral of this form. A number finite to infinity of 1 over x to a power. And these come up over and over again in what we talk about when we talk about infinite series. And so this is an introduction to get us started for that. So do you notice that in all of the cases, you have x to a power? Do you see that behavior going on? 1 over x, 1 over x squared, 1 over x to the 1/2. If I'm looking at these three areas and I was to guess which ones converge and which ones diverge, what would your brain tell you intuitively? Did you understand what I said there? Huh? No? So not doing any math. Laura, what are you thinking?
I would say the first one converges because of, like you were saying before, with it like getting closer to the line, whereas like the last one is further away, so it's less likely to, and then in the middle it's kind of like...
Not sure, right? Yeah, exactly. Do you see how this area stays kind of big? So my intuition is that that area diverges. I'm just going to write that in. Because the area stays kind of big, my intuition is that this area diverges, blows up, gets big. And the intuition is, because you see how close that function gets up there, the intuition is that that area converges, right? And then this one we're not sure about. Okay, well, let's actually do this one out and see what happens. Shall we do this one out? Let's do this one out. Okay, so let's write down an integral that describes this area. What would the integral be? The integral from 1 to infinity of 1 over x dx. Are you with me? That would be our improper integral that represents the area shown in that second picture. Would you agree with that? And what's our first step in evaluating an improper integral? Rewrite it as a limit. So are you guys writing the limit as t goes to infinity, 1 to t of 1 over x dx? Is that okay? So our first step in doing an improper integral is to put some finite limits on there to designate we've got an issue. We have some kind of asymptotic behavior, unboundedness going on. And I know AK already did this one out. The antiderivative of 1 over x. Of course, an antiderivative of 1 over x. ln, the natural log. Oh, slow down, Tina. I forgot to put my limit on there. Okay, I'd mark you wrong, right? I get marked wrong. Put my limit on there. The natural log of x from 1 to t. Are we okay, everybody, so far? And again, how do we evaluate an antiderivative with limits? We take and we plug top limit minus bottom limit. What's the natural log of 1? You guys already told me. 0, right? And what's the natural log of infinity? If I'm plugging infinity in there? Chase, what is that? That's just infinity. Infinity, right? So that sucker, natural log of infinity just blows up, right? Jake, we're all good with that, right? Infinity. So what do we say about this integral? It does what? It diverges. So this middle one actually diverges. And because this one, you can see, has less area than this one, this absolutely will diverge. And if we did out that top one, you would see that it actually converges. Okay? Do you want to do it out or do you believe me? I believe me. Absolutely. You could work it out. You could work it out. I'll show you how easy it is, right? If you were to work it out, you would simply be taking the integral from 1 to infinity of 1 over x squared dx, which is x to the negative 2, which is x to the negative 1 with a negative 1, which is 1 over infinity, which is 0. It converges. Promise you, it converges if we worked it out. P integrals are useful for when we get to next month and talk about series. And therefore, let's talk about the rule for P integrals. And I'll have you help me derive it. 1 is a cutoff point. 1 is absolutely a cutoff point. If P is 1, that integral diverges because we just probed it. If P is a half or anything less than 1, that area is big and that integral also diverges. So if P is less than or equal to 1, the integral from 1 to infinity will diverge. But if my power happens to be bigger than 1, if it's 2, if it's 3, if it's 4, if it's 5 halves, anything bigger than 1, what happens is that function gets small enough fast enough. Its behavior comes down and gets so close so fast that it causes the integral to converge. So if P is bigger than 1, that P integral converges. And you probably have a homework question. Hannah, do you have a homework question that asks you that question? Do you know? I think so. I think you do. 6. And so what you're really doing is you're looking at two cases. You've got this asymptote that's happening, and you've got behavior on the one side, and you've got behavior on the other side. And so you're trying to figure out what's happening on both sides. So the first thing I want to point out, is that whatever happens to one happens to the other because of symmetry, which means these either both will converge or they both will diverge. And so really, to figure out if it converges or diverges, you really only have to figure out one of them to start. So I would say start with just one. Because if it happens to diverge, then you don't even have to do the second one. If it happens to converge, the second one will also converge, and you'd probably want to work out what it converges to. But you just want to start with one. And so I would probably focus my attention on the first one, and I would rewrite my first one. So Gavin, to answer your question, yes, I would want to see that you're coming from the left side or the negative side to go to that T. You would say, I'm heading from 5 to 6, but I'm coming from the left side because 5 is smaller than 6. So I'm coming from the left side to approach that asymptote. And that is 1 over x minus 6 to the 2 power. So I'm just going to write it as x minus 6 to the negative 2 power. Good. I think you answered your own question, right? If you let u be x minus 6, then du is just dx, right? And so you get replaced and you get limit as t goes to 6 from the negative side. 5 is an x limit. T is also an x limit. But I think you get 1 over u squared du, right? Dx just replaces du, and x minus 6 just replaces with u. And how are you going to evaluate that out? That's u to the negative 2, right? So let me put another step in. And we add 1, divide by. What's that? Oh, undo, Tina. Dang it. Now I'm taking my antiderivative, right? Taking my antiderivative. So that's going to give me negative u to the negative 1. And I'm just simply putting that little notation there to remind myself that I have a limit that has to deal with x. And so when I plug things back in, I get negative 1 over x minus 6 from t to 5. And you guys catch me if I'm not doing it right. And then I'm going to 6 from the negative side. T minus 6, 5 minus 6. Is that what you guys got? And so 1 over 5 minus 6 is just negative 1. What happens to this piece right here? This is from Calculus 1, not Calc 2. This is Calc 1, but this is why this homework is so tricky, because you have all these stuff that you have to remember from a Calc 1. What was that?
Change it to 6.
Change it into 6.
I mean, did you change it to 6? Sorry, the integral. And the limits. The limits on the integral, did you change it to 10?
Ah, so, AK, it was 10. But the problem is, in between 5 and 10, there's an asymptote. That asymptote causes infinite area, or possible infinite area, to occur because of that asymptote. So yes, I had to rewrite the integral from 5 to 10 as 2 smaller integrals, 5 to 6 and 6 to 10. And then I said whatever happens on one happens on the other, so we're just going to focus on 5 to 6. Are you with me? You see that? So we are just focusing on 5 to 6. And when you plug a 6 in, what happens? It gives you 0 on the bottom, right? It gives you a 0. What does that mean happens? Why does that diverge? Because what? Because why is it not finite? It's not infinite? Well, so my question is, what is this limit? Ain't real. Okay. Okay. It is not a real number. I will give you that. It is not a real number. So what happens is this. We are looking at taking numbers as they get closer and closer to 6. So when we plugged 5 in, we got a negative 1, we got 1 over negative 1. Thing that is close to 6, but not quite 6, like 5.5. What happens? 5.5 minus 6 is negative 1 divided by negative 1/2. Is that okay? Which flips over and goes to positive 2. If I put another number in there, 5.75, right? I want to get closer and closer and closer to 6. 5.75 minus 6 is negative 1 over negative 0.25, which actually goes to 4. The closer and closer and closer I make these numbers to 6 from the negative side, the bigger and bigger these numbers get, because this gets smaller and smaller and smaller, and as this gets smaller, 1 divided by that number grows infinitely large. So actually, this sucker here actually grows, and it 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 grows to infinity, actually. The idea is it grows without bound. It grows to infinity. So this goes to infinity.
Would it be negative infinity?
Let me think this through.
Because you have a negative one on top. It's moved by it.
Actually, it's going to go to positive infinity
Oh, because so it goes up
because the numbers underneath, are you with me?
Yeah.
Are smaller than 6, so they'll be negative, and the negative on the negative will cancel. So it'll go to infinity.
Okay.
Either way, what happens to this integral? It diverges. This is what we call diverging behavior because the limit goes to infinity. What's that mean? Picture. It just means that that function doesn't go fast enough. Are you with me? It stays unbounded. That area stays unbounded visually. If 1/2 diverges, the whole thing diverges, and we would say that integral diverges. Okay? Told you today's going to be a fun day. Not a fun day. I've got 2 more integrals that I want to look at. X e to the negative 5x dx, and the other one is going to be 22 over 2x minus 1 times x minus 6. Let's see if we can't at least get number 4 done. In the last class, we didn't get number 5 done. So let's see if we can't get number 4 done and understood. In order to actually evaluate that whole integral out, we have to go back to a Calculus 1 concept called L'Hopital's rule. How many of you guys have ever heard of L'Hopital's rule? Some people have. Some people haven't. Okay? At hospital rule?
Yeah, we would just call it the hospital rule.
The hospital rule. L'Hopital's rule. Okay? So, once you get down to that point to where you're evaluating a limit, we will talk about L'Hopital's rule. Okay? But try this. Set it up for me. Number 4. Set that improper integral. This is type 1, Jaden, because it's got an infinity on it. So send the limit as t goes to infinity. On your test, I will have you rewrite as a limit. You get points. At the very end, you'll have to circle whether it converges and diverges. That's points. And the stuff in between to get the limit in there. That's points. Okay? And so rewriting is number 1. Rewrite this sucker as an improper integral as a limit. Okay?
Yeah.
Yeah, good. So that was like the one we just did. X e to the negative 5x. X e to the negative 5x. So 3 to infinity. So what you write? Limit as, very nice. B goes to infinity. Beautiful. So now, your next step is to integrate this sucker, right?
Why does U and D not work?
It should.
Oh, it does?
It should.
But
Integration by parts
L'Hopital's-
should work. UV minus the integral of V du, it should work.
Okay, so.
What are you letting U be?
And what? Oh, use X.
X.
And
dV is
E to the negative 5x.
e to the negative 5x dx. Integration by parts. Integration by parts. Yes, sir. on the bottom, but the x would have to stay on top.
It's all one time.
Doesn't have parentheses. You see? If it had a parentheses, then that x would have to go down, but it doesn't. So first thing is, make sure you can rewrite with the limit and you can write it appropriately. I'm going to erase the other stuff in a second here. So if you want to take a picture of it, but I want to make more space to do this one out, okay? But everybody should get that first, rewriting that limit. You rewrote that limit and now you're doing u is x, dv is e to the minus 5x dx. And when you take the antiderivative of e to the negative 5x, what is the antiderivative? It's negative 1/5 e to the minus 5x. Yes, it is. Very nice, James. Very good. Yep. Yes.
This one, this is not figure out how to go to so
It did. Notice the limits.
It's negative 1/5. Why did diversion?
Yes, isn't it interesting?
Why doesn't the-
I'll tell you why. Because if you look at the picture, this was going from 1 to infinity. This is not going 1 to infinity. If I changed my limits and went 1 to infinity, it would converge.
It's a sign of the type.
So it only works for this specific category where you're going from a finite number to infinity. This only works in that category. I love that you recognize that pattern though. Thank you for recognizing that pattern. And using integration by parts is the method. And so you're letting u be x and dv being e to the negative 5x dx. And so y'all see, right? Antiderivative of e to the negative 5x is going to give you negative 1/5 e to the negative 5x. You had problems on like this on your previous test, right? Previous homework, previous practice. And your formula was uv minus the integral of v du, right? uv minus the integral of v du. And so this converts our limit, and you should be getting, let's see what you're getting. So you're getting the limit as t goes to infinity of uv minus the integral of v du. Not a fun day. All this math. You have to be real particular, real things. And if you forget integration by parts or are struggling with integration by parts, this guy's going to be hard, right, guys? But you see it. Does everybody got it? uv minus the integral of v du. Any questions on where v, du, anything came from? Any questions? And then you have to do up that antiderivative, right? You've got an antiderivative that you're working through. I'm not going to give you something this difficult on the test, probably. Okay, this one is a messy one. This one's a messy one. I have in the past many times put this on the test. Something like that, huh? Where you have a T.
These are supposed to be.
Yep, T, and then you have to evaluate that limit out as T goes to infinity. Right? So let's see what we're doing here. minus minus is a plus. Antiderivative of e to the negative 5x is going to give me negative 1 over 25 e to the minus 5x. Step. Let me plug those values in. I've got a limit as t goes to infinity of negative 1/5 t e to the negative 5t minus 1 over 25 e to the negative 5t plus 1/5 times 3 e to the negative 15 plus 1 over 25 e to the negative 15. I want to do something because this is looking messy already.
If I could give you that answer on my test, how many points would you take off?
I don't know. I don't have my... How many points is the problem worth?
9. 9 points.
I'm not sure, Jaden, because you're not getting me a conclusion. You won't be able to conclude whether it converges or diverges.
50, so I mean, I pretty easily get the conclusion. Diverge
That's
and
true.
converge. It's pretty good math.
I love your thinking there. I am going to do something. I think I'm going to take and put my e's to the negative powers on the bottom.
Could you give me half points?
Just because I'm going to be taking a limit here in a second. So all those negative powers, I simply rewrote as 1 over e to the 15th power. So e to the negative 15 is 1 over e to the positive 15. E to the negative 5t is 1 over e to the positive 5t. Okay? That getting rid of those negative exponents helps me as I evaluate these things out. And so I know that this number here is just a finite number, and this number here is just a finite number, right? 3 over 5 e to the 15 is just a number. And the next guy's just a number. But what happens as t goes to infinity? So what happens to this piece right here? I get negative 1 over 25 e to the infinity, because 5 times infinity is infinity. And so is just what? Something really big, right? And 1 divided by something really big is just 0, really small. So this sucker here, he just goes to 0, right? He just drops out and goes to 0. So the only piece that's really giving me a dilemma, and I'm going to put it in red because it's giving me a dilemma, is this one, where I have negative 1/5 times t over e to the 5t. If I plug infinity in, what do I get on top? An infinity. And what do I get on the bottom? An infinity. And this is what we call in mathematics an indeterminate form. Indeterminate. You can also see it written indeterminate. It's said it's given different names, but the same thing. It's an indeterminate or an indeterminate form. Indeterminate form. The second one is more common. And when you have an indeterminate form with a limit, indeterminate forms are infinity over infinity, 0 over 0, 1 to the infinity. There's lots of indeterminate forms. But for our case and purpose, infinity over infinity creates this thing. Sometimes that limit actually turns out to be 1. Sometimes it turns out to be 0. Sometimes it turns out to be infinite. Our job is to figure out what it is. And so we have a rule called L'Hopital's rule, and I'm just going to summarize L'Hopital's rule for you because I know you can Google it. It's on Wikipedia. In fact, you Google L'Hopital's rule and it'll show up all over the place. Okay? A French mathematician named L'Hopital is where it comes from. L'Hopital's rule says this: if you have a limit and it turns into an indeterminate form, such as infinity over infinity, then you can evaluate that limit, somebody help me out, by doing what? Do you guys remember? Matt. Take the derivative of the top divided by the derivative on the bottom. Take the derivative on the top divided by the derivative on the bottom. That is L'Hopital's rule, and it works when you get indeterminate forms on your limit. Now, if we were a mathematician or in Calculus 1, well, mathematician, you would be like, why? Why does that work? How does that work? And then we go through and we prove it, and we show you how it all works, right? But the rest of us that aren't quite mathematically interested just says, all right, that's my rule. Let me use that rule. How do I use that rule? Here, let's use that rule. And because we're in Calc 2, not in Calc 1, I'm not going to prove it right now, okay? Don't have time. We just don't have time to go through the whole proof. So let's use this rule to evaluate this limit, which means I have to take a derivative on top and I have to take a derivative on the bottom. So applying L'Hopital's rule right here to this limit where I got infinity over infinity, if I apply L'Hopital's rule that says take the derivative of this function. So it's negative 1/5 times, so I'll just leave that negative 1/5 in there, times, what's the derivative on top? Derivative of t is just 1. Derivative of e to the 5t is just 5e to the 5t, right? Well, okay, so the 1/5, there's a lot we could do with it. First, we could pull it outside of our limit if we wanted to and just ignore it completely. Secondly, we could put it on top, Grant, if you wanted, and make it negative 1/5 times t, so the derivative of negative 1/5 times t is just negative 1/5. So you could just use it and put it on top if you want. But the big thing is it's just a constant. And because I'm not worried about having a t involved, what I'm really worried about is what happens as t goes to infinity. That negative 1/5 actually becomes unimportant. But I could either pull it out and multiply, or I could keep it on top if I wanted to, or I could keep it in front. And so what I have, though, is what happens as t goes to infinity, that bottom blows up. And 1 over something really big, what does this whole thing come? It becomes 0. And 0 times negative 1/5 is still just 0. And so this thing also goes to 0. So that tells me that my limit actually is just what? 3 over 5 e to the 15 plus 1 over 25 e to the 15. That answer is finite. And so what would we say this limit does? This limit converges. Let's just talk it through quick. We won't have enough time to finish it. I know we won't because it's a long integral. But let's talk it through. Our first step would be to turn it into a limit, right? So the very first step, step number 1, is we would rewrite this as a limit. But hang on. I don't know. Did I give enough time for this other one? Is everybody okay with the other one? Grant, did I give enough time on that other one? Were you okay with that other one? Yep. Is everybody okay with that? On this one here, I want to ask, what would my method be? How would I evaluate that integral? Hannah knows. She did this one on her homework. What are you going to use, Hannah? Partial fractions. Guys, partial fractions. In other words, you're going to, Yusuke, did you do this one too, maybe? So you're going to take this guy and rewrite it as partial fractions. Now, so that's your step. You're going to rewrite this as partial fractions. I'm going to tell you that to finish this problem, you are going to wind up, so I'm going to tell you right away, as you work this problem out, and you're welcome to sit and work through this problem right now if you want to. As you go down, you will eventually get to this here in your limit case. You know how we got to infinity over infinity? You will get to another indeterminate form, negative infinity plus positive infinity.
It's not just zero.
And the second I put in this,
Is that zero?
thing that makes
You think it's zero, but unfortunately it's not necessarily zero because maybe this infinity happens to be a little bigger infinity than the other infinity. Maybe it's twice as big, or maybe it's infinity plus 10 with a negative infinity and you have a difference 10, not 0. So this is another what we call indeterminate form. When you get to this, you are going to use a logarithm rule to finish the problem. Okay, so I'm going to write down a couple logarithm rules for everybody, all right? I'm going to give you the tools you need to complete this problem, okay? And you're like, oh my God, Tina, we better do this sucker out. But here we go. Logarithms, do you remember? Logarithms are just exponents. And so logarithm rules kind of follow exponent rules. Logarithms are just exponents, so they kind of follow those rules. If I have x cubed times x squared, how do I put those two exponents together? What do? I add them. To combine two separate bases together with exponents, I add them. It's that kind of idea. Yeah, question. Go ahead. Yep. If I want to put these together into a single logarithm, how do I write that? If I want to put these two together in a single logarithm, how do I write that? If you have two separate logarithms with a plus sign, remember, these guys are just exponents. How do we put them together? We put them together in a logarithm using multiplication. Again, if we were mathematicians, we would go back and evaluate and prove why this is true. That would be something we would be interested in doing. But I'm just going to give you that rule. This is the first rule. If you have two logarithms with the same base, in other words, natural logs, and you're adding them together, they go into a single exponent with multiplication. Single logarithm with an exponent. And if you have subtraction, they go into a single logarithm as division. And one other logarithm rule you're going to need is this one here. If you have a natural log of a value but some kind of coefficient in front, you can bring that coefficient up as an exponent or a power on that inside thing. I think what makes Calculus 2 so hard is not necessarily the Calc 2 part, which is take a limit. Rewrite it and use use integration by parts or partial fractions. That actually becomes easy. The hard part is the second part, which is coming up with these rules from the past and plugging them in and applying them into proper places. I think that is where it gets really tricky for us in Calc 2, is taking previous knowledge and applying it to our situations. So I'm just going to say that this problem here requires these logarithm rules. I actually have a video made because this problem tends to give everybody trouble. So I made a video, and I'll make sure I send that video out so that you have it for when you do that homework problem, if you want to follow along, okay? And you're welcome to start it now. I just know we're not going to get all the way through. And so I just want to make sure I give you enough information to complete the problem on your own. AK.
The first question, number 3.
The first question?
The one we did first.
Yes. The first question, the very, very first question, this one up here that I erased. Yes.
Let me just read. What's the limit?
Because if you just integrate with the limits, you get a finite answer. The problem is there's an asymptote, and we can't integrate through an asymptote. Like if you draw the picture, 1 over x minus 6 squared on Desmos, do you know what I'm saying, AK? There's an asymptote that happens, and your graph goes up, doesn't it? Do you see it? It gives you an asymptote behavior. It does go up at 6. And that's why we had to break it up into 2 smaller integrals. 5 to 6, 6 to 10. And then we just looked at one of them. Okay? Then you have to be able to look at it, because I'm going to say it's an improper integral, which to you says there's an asymptote. Either it's an infinite asymptote with infinity, where x is going to infinity, or there's something in there that's causing the asymptote. And you have to look at that problem and say, what's going to make my bottom 0? Do you see what I'm saying? You just have to look and say, what would be the bad one? 6. Do you see what I'm saying? I'll probably give you a picture because I like to give pictures. But, yeah. Question. All right. Different problem. Okay. Okay. We can still talk. Absolutely.
I don't think I have a problem that works. Seems like you have a problem. Yeah, no, I think Silas has a problem. The thing I'm working on, it has to, like, I don't, if it works, if it's not giving me like a, it's not like I would type something in wrong, right?
Yeah.
Or else something else. It's really just like,
Okay.
yeah,
Let's see. I'll have to
Which makes
take a
no
look
sense,
and do a
because,
time this week.
like, how is that my problem? I've tested it literally like 50 times
But
already.
I'm going to go home up to my office now at 2 o'clock and I'm going to leave it till 6. So we could actually sit down. If you're busy today. Oh, you have class from 2 to 6?
Yeah, I have class from 12:30 all the way to
Oh, so-
4:40.
Oh, no. You guys are welcome to go if you want to go. If you're still working homeworks or have questions that I can help with, I'm going to stick around and help you with questions. Okay?